So today's session, I will discuss questions related to week 7. Okay, so this will help you in solving the week 7 assignment question. So I'll go one by one. This is first question, what is the effect on the settling time of a system when we are increasing the integral gain of the PID controller? Okay, so what should be the answer for this? Any, are you remember? Right? What will be the answer? Any guess? It should be increase or decrease settling time. Okay, normally say once I will repeat this question. So any system is given and let's say this is G of S, okay, and some PID controller will be there. Let's say uh, C of S controller, okay, and here one summer block will be there. This is G1 I am saying. So C of S and R of S. So if we are increasing this integral, this Kp plus Ki by S, okay, plus Kd into S. This is PID controller. Okay. So if we are increasing the integral gain, this Ki, if we are increasing, what will be the effect on the settling time of the system? Any guess? What should be the correct answer? Anyone can reply? What is settling time? Can anyone tell? What is settling time? Have you gone through week 7 video lectures? What is settling
Yes,
time?
sir. Yes, sir.
What is settling time? What is TS?
Time to reach 50% of the
Final value.
final value, sir.
50%. That is rise time, no? I think.
Yes, sir. Yes.
See, this is let's
It's
say
90%, sir.
90%, 0.9. Okay.
Yes, sir. Yes. Yes.
So we'll see one example. Okay. So let's say I'm not using any controller. So let's say our transfer function is 1 upon 1 plus s. Okay. This g of s is 1 divided by 1 plus s. Okay. Simple without any controller. So okay, this one. Okay. So minus plus. What will be the c by r? So c by r will be equal to cs by rs. This is equal to g by 1 plus c. So that is 1 by 1 plus s divided by 1 plus 1 by 1 plus s. So what will be the value? 1 by s plus
S plus
2.
2.
Okay. So if I am applying a step input, rs is equal to 1 by s. So what is the settling time here? Let's say output we can write. So what is output? Y of t is equal to, so first y of s we can write. Y of s is equal to 1 by s into s plus 2. Okay. So if we'll factorize this, what will be the value? S is equal to 0. So this will be 1 by 2 by s, and here s equal to minus 2. So minus 1 by 2 upon s plus 2. Is it correct?
Yes, sir. Yes, sir.
Okay. So one second. So what will be the y of t? Y of t is equal to 1 by 2 u of t
U of t,
minus
yes,
1
sir.
to e to power minus 2t.
E power minus 2t. U of t.
Okay, so what will be the final value here? Steady state value. This will become 0. See how it will be. One, this is a step value. One step is there, okay, plus one exponential decaying signal is there. Okay, so this signal will go like this, and where it will settle? It will settle at 1 by 2. Is it correct? See, this is y of t. It is correct, na? At t tends to infinity, it will settle at 1 by 2. Correct only? This part will become 0, exponential.
Yes, sir. Yes, sir. Yes, sir. E to the power of
So,
minus infinity
as
0.
per definition, let's say 90%. Oh, what is the time when it will reach 90%? Okay, that will be the settling time. Okay, so we can solve this equation. Let's say y of t is equal to 1 by 2 minus 1 by 2 e to the power minus 2t. So final value is 1 by 2. What is 90%? 1 by 2 into 0.9. This should be equal to 1 by 2 minus 1 by 2 e to the power minus 2t. So from here we will get the value of the settling time, Ts. Okay. So I am calculating, you can also calculate. So 2 will be cancelled both sides. 0.9 is equal to 1 minus e to the power minus 2t, and e to the power minus 2t is equal to 0.1. Is it correct?
Yes, sir.
So
Yes, sir.
what will be the t value? Ln we can take both sides. So minus 2t is equal to ln 0.1. Okay. Ln of 0.1 divided by minus 2. Ln 0.1 divided by minus 2. We are getting 1.151. T is equal to 1.151 second. Correct?
Yes, sir. Yes, sir.
Okay.
1.1512.
So let's add a integral controller. Then what will happen? Okay. In same thing. So I'm adding a integral controller 1 by s. Let's say 1 by s only. Here the transfer function was 1 by s plus 1. So 1 by s plus 1. Okay. What will be the transfer function here? That will be 1 by s square plus s divided by 1 plus 1 by s square plus s. Okay. This is transfer function closed loop. So that will be 1 by s square plus s plus 1. Correct? So we already know this kind of system. What is the settling time here? What is the settling time formula? Remember 4 tau or 5 tau, that kind of thing, where tau is equal to 1 upon zeta omega n. Ts is equal to 4 tau for 2%. What is 2% and 5%? See, error band will be there, na? 2% means it will reach 98%, 98, 0.98. This is for, 1 second, this is for 0%, it will be 5 tau. Okay. For 2%, it is 4 tau. So 2% means it will reach 0.98. Correct? So this is STD state value. 0.98 means 98%. 2% of gap will be there. Is it clear?
Yes, sir.
Okay. So what is here? Omega n is 1. Omega n is 1. 2 zeta. Omega n is equal to how much? 1. Zeta
1, sir.
omega
1.
n how much? 0,
0.5.
0.5. So what is the settling time? Ts. Ts is equal to 4 by zeta omega n. Correct? 4 by 0.5. It will be 8. Correct? So what is happening? Our settling time is increasing if we are adding an integral gain. If we will increase this gain, then it will increase. Okay. So we will see the option. Ts will increase. Okay, I will write a table here that you can memorize. So TS is increasing. Is it clear? Okay. So PID controller, if we are increasing some values, what will happen? That I am writing here. PID controller will be there. So KP, KI, and KD. Okay. So if we'll increase all this value, then what will happen? That I am summarizing here. Okay. So if KP we are increasing, percentage overshoot. 1 second. Okay. So this value will increase here if we are increasing KP. KI if we are increasing, what will happen? It will also increase. And KD if we are increasing, it will decrease. All of you know this earlier? This have you studied this one? What will happen to the settling time? So for K3 if we are increasing, what will happen? This will not affect much. So it will not affect much. We cannot say minimal impact. So this one will increase if we are increasing KI, settling time will increase, and KD if we are increasing, it will decrease. Okay. And other one term is there, steady state error. Okay. So if we are increasing KP, it will decrease. Okay. And KI if we are increasing, it will become 0. It will tend towards 0. Okay. And here it will KD will not impact. Is this clear up now? Should I proceed to the next question? Or any doubt is there, you can ask. See, like,
Sir, this is all are increasing, sir.
all are increasing. Increasing
Okay, sir.
KP, KI,
Uh-huh.
and
Okay, sir.
KD.
Okay, okay. That's not, sir. In the earlier problem, how did you get that? Just to show this, not this one, sir. Last step, sir.
Okay.
What is that? This TS is called 4 by zeta omega. How did you get it, sir?
See, omega, this transfer function we are getting, na?
Yes, sir. Yes, sir.
So transfer function we are getting this. This is up to now. It is clear. This transfer
Up to
function.
only last step, sir. TS is
Okay.
equal to 4 zeta omega.
See, this is a standard formula. Setting time.
Okay, sir. Okay.
For
Okay.
second order
Uh-huh.
transfer function will be there. Okay.
Okay, sir. Okay.
Like
Okay. Okay.
omega
Okay.
n
Correct.
square divided by s square plus 2 zeta omega ns plus omega n square. Let's say this is our transfer function, closed loop. Okay.
Okay, sir. Okay.
So for 2%, I'm writing here the formula 2% and 0%. 0% means it will reach to, this is band. Okay. Let's say
Yes,
our
sir.
final value is this one. So 0% means it will reach to this point. Okay. 2% means it will reach to 98%. Okay. This 2% gap will be there. So for 2%, the settling time formula will be 4 tau, and 0% it will be 5 tau. So what is tau here in second order system? 4 upon it will be zeta omega n, and this will be 5 by zeta omega. Is it clear? This is a
Okay,
standard.
sir.
You should remember all this time response formula. All you should remember. Okay.
Okay, sir. Okay. Okay. Right, sir. Thank you.
Okay. Okay. Thank you. So this is a compensator based question, lead like compensator. Okay. So I'm just explaining it in a simple way. So one compensator is given, and this is multiple select type question, like more than one option can be correct. Okay. So we'll see. GS is a lead compensator if Z less than P. So I'm just calculating angle of this one. Okay. GC of J omega will be equal to Z plus J omega divided by P plus j omega, correct? So what will be the angle? Angle GC j omega will be equal to tan inverse omega by z, okay, minus tan inverse omega by p. Okay, is it clear up to now? So see, one statement is there. Lead means it will contribute positive angle. Lag means, lag compensator means it will contribute negative angle. Okay, so if z will be less than p, what will be the angle? Already angle I have written here. If z will be less than p, then what will be the angle? Can anyone tell whether it will be positive or negative? This angle. See, z is less than p. What is if like tan theta? Okay, if theta will no tan inverse something constant. Okay, so some constant will increase means what will happen to theta? Theta will increase only.
Constant divided by something, no, sir.
See, this is omega divided by z.
Om- Omega is constant, sir. Z and P are varied. So if
Okay.
it is Z is less means it will be more angle, sir.
This is so this will be positive, correct?
Yes, yes, sir. Yes, sir. Yes, sir.
So ZC is a
But
lead. So, but question is asking opposite. See, this also we should be careful. Which of the following statement is not correct? Okay. So this is correct only. But question is asking which is not correct. So sometimes we'll do the mistake like we'll find the correct option and that will tick out. So Z less than P, Z less than P, angle will be positive. Means lead compensator. Z less than P, lag compensator. This is incorrect. Okay. G j omega is always positive if GCF is a lag compensator. Lag compensator means angle contribution will be negative. So this is incorrect. Okay. And this is correct. Since these two statements are correct, but it is asking which are not correct. So what will be the answer? This and these two options are not correct. Is it clear to all?
sir, last two are angle one, and
See,
previous
lead.
two ones are magnitude ones, sir.
No, no. Which one?
Uh,
Can
Sir,
you repeat?
last two bits are regarding angle. First
Angle
two
one.
bits, okay, angles one. First
First
two
one is
bits are not
asking it will be a lead compensator or lag compensator. It is
okay.
not
Same,
asking.
same. Okay,
Uh,
sir. Same
say,
question.
Same
Okay, sir.
question, options are there. These are four options. Okay.
Okay, sir. Okay, okay. Right,
So
sir. Right, sir.
lead means it should contribute always positive angle. Lag means it will contribute negative angle for all value of omega. Okay. So
Okay, sir.
that's
Okay.
what written here. Always positive is a lag. Lag means always negative. So it is incorrect. This is always positive lead compens. Lead means always positive. So these two are correct and these two is incorrect. But according to the question, these two are the options which are not correct. Is it clear to all?
Yes, sir. Yes, sir.
Okay. 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 Moving to the next question. Again, one table I have written here there already. So if KD by increasing the KD gain of a PID compensated system, the percentage overshoot of the compensated system decreases. Already I have written here. I'll show you once. So percentage overshoot, what will happen? That will decrease. So this, other than analysis in the exam, we should remember this table. Okay, that's analytically also we can do, or we can see this thing with MATLAB also. Like MATLAB, you can check the step response. Okay, and you can vary the values, but better to remember that table. So this is true or false? What will be the answer?
True, sir. True.
This is true only. By increasing the this one, the percentage overshoot will decrease. So this is the correct option. Okay. So moving to the next question. Okay. How we can solve this question? This is easy only. Any idea? PID controller is given. Okay. And zeta value is given, omega n is given. So just we have to find the second order transfer function equivalent, and we can find the zeta and omega n. Okay. So this will be like, system will be like this: Kp plus Ki by S. Okay. And here this function will be there. So 1 by S square plus 3s plus 2. And this summer block will be here. Is it correct? No, Kp plus S Kd. The second is Kd. Kp plus S into Kd. Is it clear up to now? So what will be the
Yes, sir. Yes.
transfer function? So that will be g by 1 plus g. So Kp plus S into Kd divided by S square plus 3s plus 2, correct, plus Kp plus Skd. Is it correct?
Yes, sir. Yes, sir. Correct.
Simple only. So from here just we can match with this one. Okay. So correct, like this equation will be S square plus 3 plus Kd into S plus 2 plus Kp. Correct only. So what is omega n? This one omega n, and what will be this value? Omega n square. Okay. So 3 square is equal to 2 plus Kp. Is that correct? So what will be the Kp value? Kp is equal to 9 minus 2. Kp will be equal to 9 minus 2 is equal to 7. And what will be the Kd value? Also can calculate simultaneously. So 2 zeta omega n is equal to 3 plus Kd. Is it correct? 2 into zeta, how much? 0.75 into omega n 3 equal to 3 plus Kd. What will be the Kd value from here? So 2 into 7.5, 1.5, 1.5 into 3, 4.5, 4.5 minus 3, 1.5. So Kd will be equal to 1.5.
0.5, sir.
Okay. So this is 1.5, and this will be equal to how much? 7. Is it clear to all? Now, should I proceed to the next question?
Yes, sir. Yes, sir.
Oh, okay. So see, this is one very good concept. Like, competitive exam also based on this question will be asked. So steady state error already I explained earlier. What is steady? So this is a simple transfer function. Here this part is the disturbance input. Okay, DFS. So what will be the steady state error due to disturbance? So normal any step input will be there due to R of S. What will be the steady state error? So we can write thus transfer function first. This is first steady state error due to input. Okay. So this is E of S. Okay, and this is R of L. So if you will write the transfer function between E of S and R of S, so E of S divided by R of S, this will, what is the forward path? Here 1 only. Here to here gain is 1. So forward path divided by 1 plus loop. So 1 plus G1S into GS. Okay. So this is total GS. So that's what already I have explained. Steady state error is equal to S into RS divided by 1 plus GS. This GS is the open loop transfer function of the unity equivalent system. Okay. This kind, let's say this is GS, and this kind of system will be there. Okay. So directly we can find the steady state error is equal to S into RS divided by 1 plus this G equivalent. So here G equivalent is G1 into G. Okay. What is the error due to the disturbance input? This is this DFS. Okay. So we'll write the transfer function EFS by DFS. If you'll see the forward path, so from here to here. Okay. That is their minus is there, so that minus GFS. So minus GFS divided by 1 plus loop gain. Okay, so loop gain will be 1 minus loop gain. So 1 minus and this will be minus. So that will be 1 plus G1S into GS. So for disturbance input, steady state error will be equal to this one. Limit S tends to 0, S into minus G1 of S, okay, into ds divided by 1 plus G1 S into GS. Is it clear? Hello?
Sir,
Is this, you can ask again, I will just explain.
uh,
If,
how do we get minus GS, sir? Because of negative
yes, see,
feedback, sir?
how forward path, this is one point, EFS, steady state error. Na? So error means, what is error? R of S minus C of S. Okay, this is reference input, this is feedback we are taking, CFS. So this subtraction is the error, EFS. Okay, so I am writing the transfer function between this point and this point. The first transfer function is between this point and this point, E by R. So E by R means the R to E gain will be 1, forward path. So that is 1 divided by 1 minus, this is loop. Second case I am writing due to disturbance. So disturbance is here and this E point is here. So if you will come in this way, so up to ES, the gain will be minus GS. Okay, forward path gain. So minus GS divided by 1 minus G1 of S into GS. Is it clear?
Yes, sir. Clear, sir.
Okay, so these two things we should remember. ESS for due to disturbance will be limit S tends to 0, S into minus G, that will be minus GS in G into DS, minus G into DS, G of S into DS divided by 1 plus G1S into GS. Okay, so this one question I have given. Can you try what will be the ESS due to a step input? Okay, a step input, first question, and second question due to a step disturbance. You check the plus minus sign and try to solve it. Okay, I will write the formula also here. See, here one change I have done is that visual to you? One difference is there compare in these two diagrams. So total steady state error will be equal to due to RS and due to DS. Okay, if both error we will add, then we will find the total steady state error. Should I explain it or you can try? Hello? See, normal error I will write. So normal due to a step input, ESS will be due to a step RFS. So due to RFS, okay. ESS will be limit S tends to 0, S into RS, 1 by S divided by 1 plus GS. So GS will be this and this multiplication. Okay. So 10 by S plus 2 into 1 by S plus 5. Okay. So this SS will cancel. So that will be 1 by 1 plus, and this 10 divided by 5 into 2. So 10 by 10, 1. This is equal to 0.5. Okay. So this error is due to the step reference input. Is it clear? This is due to a step reference input. So what will be due to the step disturbance input? Question 2. This is question 1 already I have solved. what will be the error due to a step disturbance input? Is it clear, this first explanation? Hello, can anyone reply?
Sir, how do we get a limit s tends to 0 s into instead of numerator we have written only one unit step function, sir. That's we are input is
Which one? Which one? Step input.
step input. Okay, sir. Okay, okay.
ESS formula is there, na? This is the formula for ESS. S tends to
Okay,
0, S into RS. What is RS? This is
okay,
reference
sir. Okay.
input. Okay.
Reference input. Okay, sir. Okay, okay, right, sir.
So S into 1 by S divided by 1 plus GS. So see, first like both we will make one DS is equal to 0. So these two inputs are there, na? So one by one we will calculate. If we are calculating error due to this one, then DS will be 0. First case DS will be 0. Okay. Second case, if we are calculating error due to DS, in that case we will assume RS is equal to 0. Okay. So if ds is equal to 0, our function will be 10 by s plus 2 into 1 by s plus 5. So that gs I have written here. 1 by s into rs divided by 1 plus gs. What is gs? Gs is multiplication of these two. Is it clear now?
Yes, sir. Yes, sir. As per formula, it's okay, sir.
Okay. Okay. So what will be the second thing? Just I will write. So ESS due to DS disturbance, unit disturbance. So limit s tends to 0, s into ds. So ds is 1 by s into what was there? Minus gs. So minus 1 by s plus 5 divided by what will be here? 1 plus 10 by s plus 2 into 1 by s plus 5. Is it correct? The mistake is there. So what will be the value here? The ss will cancel. So that is minus 1 by 5 divided by what will be here? Uh, Minus 1 by 5 divided by here. Previous also same thing we are writing. What will be the value? 2 only. 1 second. This is 5 into 2, 10. 10. So 5 into 2, 10, 10. What will be the value? Here it will be 2 only, I think. Correct? So minus 0.1. Is it correct? Any mistake is there?
Correct, sir. Correct, sir.
See, I have done some mistake. Will remind you. So this thing we should be careful. What changes I have done here? Here I have given plus. So see here. Here I have given disturbance input as plus. What I have written here? Here I have written as minus.
Yes,
So
sir.
if minus is there means if we'll find this EFS. Okay. So like output EFS by DFS I have written here. So here minus minus will become plus. Okay. This minus and this minus multiplication will become plus, and here it will be plus. Okay. This point here it will be plus. So here also it will be plus, and the error will be here 0.1. So if question will be asked, what is the total error due to a step input and a step disturbance input? So total will be what? Total will be 0.5 plus 0.1 equal to 0.5 plus 0.1. This is equal to 0.6. Okay. And if it will be like previous case, if here positive will be there, okay, if that will be positive, then ESS will be, and this will come as negative. So ESS will be 0.5 minus 0.1 equal to 0.4. Okay. If this will be positive, is it clear? But here since this was negative, so ESS will be, total ESS will be 0.6. Is it clear to all? So now,
Yes, sir. Clear, sir. Okay.
okay, okay. So this is one 2 marks gate question 2022. I will just give it to you. It's easy only. Already all the things I have told uh, based on the same concept. Okay. So what will be the error due to a unit step disturbance? ESS due to unit step disturbance. Okay. Very simple question. Already concept I have explained. You can try it. You can just, if you know the concept, one minute is more than enough to solve this question. Question is clear to all? Hello.
Yes, sir. Yes, sir.
Okay, you can try once. Like I will give you 1 minute. You can try it. Just whatever I explained accordingly, you can solve it. You check the sign also, plus and minus. So here plus is given. Okay. Anyone got the answer? So like here we have to found the error due to the step disturbance. ds is equal to 1 by s. So what will be the, this is E of s or E of infinity we have to find. Okay, you got the answer? Should I solve it?
Yes, sir. Please solve it.
Okay, let's see. Like E of s by d of s, we can write, I'm not writing the formula directly. So I will write E of s, okay, divided by d of s. E of s divided by d of s. So this is our error is equal to, what is the forward path? Forward path will be like this one up to here. Okay. So that is minus 1 by s into s plus 10. So minus 1 by s into s plus 10. Okay. Divided by 1 minus loop gain. So 1 minus minus. So it will be plus 10 by s into s plus 10. Is it clear? This transfer function, this E of s is there, this node is there, okay, and this node is D of s. So forward path is minus 1 by s into s plus 10, and the loop gain is minus 10 by s into s plus 10. Okay, so the transfer function is this divided by 1 minus loop gain. So loop gain will be 10 by s into s plus 10. Is it clear up to now?
Yes, sir. Yes, sir.
So we have to find infinity. So final value theorem we can apply here. So E of infinity is equal to limit s tends to 0, okay, s into es. Okay, so that will be es is equal to ds into this one. So that will be limit s tends to 0, okay, s. So es will be ds into this one into ds. That will be es. Okay, so s into ds how much? 1 by s, okay, into minus 1 by s into s plus 10 divided by 1 plus 10 by s into s plus 10. Is it clear up to now? This will be E infinity. Is it clear?
Yes, sir. Yes.
So if we put s is equal to 0, so this s and this s will cancel. Okay. And here it will be, if I am multiplying s into s plus 10, so that what will be the value? If we'll multiply by s, numerator and denominator. So in numerator it will be equal to minus 1 by 10, correct? Divided by this will become 0, and this is 10 by 10, 1. So this will be equal to minus 0.1. Minus 0.1. Is it clear? Otherwise, I will explain again.
Sir, please explain how we get ES by DS is equal. That how we get ES part as minus 1 by S into S plus 10, sir.
Which
DS
one?
is okay, sir. It's
Which one?
first
This
step, sir.
this explanation.
Yes, yes, sir. Yes, yes.
See, just I will take it to the next page. 1 second. Once again I will write the expression for this one. This is DFS. Okay. This is EFS. Correct.
Yes, sir.
So, like Mason's gain formula I am applying.
Okay,
So
sir. Okay.
here to here, what is the forward path? From here we will go in this way up to here.
Yes. Okay, sir.
So
Okay.
ES by DS, okay, is equal to, our forward path gain will be minus 1 by S into S plus 10. So minus 1 by S into S plus 10.
Okay, sir. Okay.
And loop is there, one loop is there, that loop is this one.
Yes,
Okay.
sir. Complete
So
loop. Okay, sir.
forward path divided by 1 minus loop gain. So loop
Okay.
gain will be equal to minus 10 by S into S plus 10. Okay. So
Okay, sir.
1 minus loop gain I am doing. So that will be 1 plus 10 by S into S plus 10. Is it
Okay,
clear
sir.
up to
Clear.
now? So
Clear, sir. Clear.
now ES will be equal to DS into minus 1 by S into S plus 10. Okay. 1 plus 10 by S into S plus 10. Okay. And we have to compute E infinity, steady state error. Okay. So E infinity will be equal to limit S tends to 0, S into ES. Okay. And what is DS value? DS is a step input, so it will be 1 by S, a step disturbance. Okay. So again, I'm writing the same thing. Limit S tends to 0. Okay. S into ES. So ES is this one. So DS 1 by S into 1 by S into minus 1 by S into S plus 10, numerator. And denominator it will be 1 plus 10 by S into S plus 10. Is it clear up to now?
Okay. Clear, sir. Clear. Got it.
So SS will cancel, and if we'll multiply by S in numerator and denominator, so what will happen? Then ES E infinity will become limit S tends to 0. What I have done? Multiply by S in numerator and denominator. So it will be minus 1 by S plus 10 divided by this S plus 10 by S plus 10. Clear up to now? So this S will become 0, and in numerator it will be equal to, so E infinity will go, numerator it will be equal to minus 1 by 10, correct? And denominator this S will become 0, and this 10 by 10 equal 1. So that is minus 0.1. Is it clear now?
Yes, sir. Yes, sir. Clear, sir.
Okay. So see, mostly mistake what we'll do, minus sign sometime we'll forward. Okay. So let's put like this. minus also in fill in the blanks type question, we should put minus also. So this is the final answer. So if you know this step in within 1 minute, you can solve this 2 marks question. Okay. Should I move to the next question?
Yes, sir.
Okay, okay, okay. So this is visible, this points. 1 second. This 1 second. This data are visible. J and
Yes, sir. Yes, sir.
okay. So some values are given here. This is see sometime in gate also this kind of question can be asked. It will look big question, but it will be easy only. Some block diagram is given, similar kind of the disturbance kind of thing. Okay, this is disturbance input, this is reference input, and this is reference output. Okay, so some value is given, like this satellite attitude control problem is given below. Here j is equal to 10, its j value is equal to 10, satellite attitude theta, and actual attitude output theta. Okay, sensor 1 volt per radian, and hy is here feedback, and hr is also 1. So we can write it in simple way. This is 1 only, so no need to write anything. This is theta r. Okay, and summer block is there. Here also 1 is there, and dc of s. So this is controller. So if dc of s is kp, so we have to put here kp, and this also summer block is there, disturbance input, and here what will have multiply, we can multiply it 1 by 10 s into 1 by s, so 1 by 10 s square. Okay, and this is theta. Is it clear up to now? Hello, just I have kept the value. See, j is equal to 10. Okay, so 1 by 10 in 1 by 10 s into 1 by s, so 1 by 10 s square. Okay,
Okay, sir. Okay, okay.
so now the question is like the range of kp for which our system is unstable. So how we can calculate this? What will be the value of kp for which system is stable? This is theta and theta. Can anyone tell a step? What, how we can proceed for this one? Range of k we have to find for which our system is stable. Any guess how we can proceed? What will be the answer? See, just RH criteria already have discussed, na? RH criteria. I'm going to write the closed loop transfer function. This is disturbance. So normal we have to theta by theta r, we have to find theta by theta r. What will be the value? Kp by 10 s square. Okay, 1 plus Kp by 10 s square. Is it clear? So
Yes, yes, sir.
the characteristic equation will be, what will be the characteristic equation? That will be 10 s square plus Kp. Okay, correct only.
Yes, sir.
So what is the rule for stable system? Our poles will be in the left hand side. Okay, poles should be in the LHS. Correct only. So if Kp will become negative, then what will happen? Pole will be, where will be the pole location? If Kp is negative, where will be our pole? Two poles are there, no? Second order system. So 10 s square minus Kp is equal to 0, and s will be equal to what? Kp by 10. Correct? So we are seeing that our pole is going in the RHS. Is it correct?
Yes,
So
sir. Yes, sir.
if Kp is negative, means Kp less than 0, our system will be unstable. So what will be the answer? This one is the answer.
Okay, sir. Okay. Okay.
Okay.
Sir, how do we guess that he has asked for theta by theta?
See, this is disturbance input. Anyway, this is, if a specific it will not ask, like, see, this is disturbance. So normally it is asking for this stability of the system. So if disturbance, any points will be given about disturbance, will not be given, then we'll assume it as a zero. Okay.
Okay, sir. Okay, okay.
Normally we'll find the stability with respect to these 2 points only. But if it
Okay,
will ask like what will be the stability with respect to disturbance, then we'll see that. Okay.
okay, sir. Okay.
So if Kp is equal to 100, okay, what will be the nature of the system? Here Kp is equal to 100. What will happen? See here already I'm showing you. So Kp is 100. What will be the nature of the system? So characteristic equation already we know, and that is 10s square plus Kp. So 10s square plus Kp, and Kp is equal to 100. So what will be the option? Is it stable, unstable, marginally stable? What will be the answer? What is the meaning of marginal stable?
Roots will be on the imaginary axis, sir.
So for this, what will happen? If
Root will
Kp
be
is equal to
on,
100.
yes, sir, imaginary axis, plus or minus
So
root
10
can.
s square plus 100 is equal to 0, and s square will be equal to minus 10. Correct? So s is equal to plus minus j under root 10. Okay. Will come on imaginary axis. So this is the correct option. System will be marginally stable.
Yes, sir. Yes, sir.
Okay. 1 second. Hmm. This is other question. So PD controller if we are using, okay. So PD means this controller will be PD controller here, that is there. Uh, this controller is PD controller, okay. So PD means 10 plus 2s, okay. So the acceleration constant with respect to reference theta, okay. 10 plus 2s, and 1 second. Another question is there. Uh, and what is here? 1 by 10s square, correct? Already, what is the acceleration constant? Can anyone tell? What is the acceleration constant? Ka value. K is equal to limit s tends to 0 and s square into g equivalent of s. Correct? This is acceleration constant.
Yes, sir. Yes.
So what is g equivalent here? That will be 10 plus 2s by 10s square. Correct? Equal to limit s tends to 0. Okay. S square into 10 plus 2s divided by 10s square. So s square will be cancelled. So what will be the value? That will be, this is 0, 10 by 10 it will equal to 1. Correct?
Yes, sir.
Okay. Okay. So coming to the next question. So if we are using PI controller with respect to response, the type of the system we have to find. So what is type of the system? Can anyone of you tell what is type of the system?
Number of poles at origin will define the type of the system, sir.
Okay. So 1 second. And another question is, okay. So how we can calculate Kp plus Ki dc of S, na? Kp plus Ki Kp plus Ki by S, and here it is 1 by 10 S square. Okay. What is the type of the system? This is theta r and theta of S. Correct? How we can calculate the type?
We have to take closed loop and we have to equal it to unity feedback, sir.
Okay, correct only. So we can take the closed loop system, but here also we can do na KPS. Why it is not possible here? KPS plus Ki by S, correct? Into 1 by 10 S square, correct? That will be unity equivalent only, na?
Yes, sir. Yes, yes, sir. Yes, sir.
But
Same.
but,
Then
but why it is? That is correct only. Like if any transfer function will be given, na, that will we will first convert into the unity equivalent and then we'll find the type. But here, what is the type? It's correct only because no need to convert.
three, sir.
It's
Three.
directly we are getting. So Kp plus, because this is unity feedback only. Okay.
Yes, sir. Yes, yes. No
Kp
need to
plus
convert. Yes, sir.
Kps plus Ki. Okay. Divided by 10 S cube. So type will be 3.
Three, sir. Three.
Okay. Type is equal to 3. I think next question it will be
Sir,
like
it
that.
is same problem, sir. For all these same data we are using.
Hmm?
1 by 10 S square, where do you get, sir?
Which one? Same only. Previous question data
Okay,
only.
okay, okay,
That
okay, okay.
one common question.
Okay, okay,
So
sir.
based
Okay.
on this only all data I have taken.
Okay, sir.
So
Okay.
this is 1 by J's and that is 1 by 10 S square. Okay.
Okay, sir. Okay, okay. Right, sir. Right. Thank you, sir.
So 1 second. And next question. Kp plus Ki by S plus Kd S. Here what will happen? So okay, with respect to disturbance omega. See here that what you told here we have to think in that way. So what is the type of system here we have to go? Kp plus Ki by S plus Kd into S. Okay. Mm, here plus and this is disturbance. Okay. And this is 1 by 10 S square and here plus minus. So with respect to disturbance means this thing will assume 0. Rs is equal to 0. At a time we'll do calculation with respect to 1 only. Okay. So what is the type of system with respect to disturbance omega? So this is output. Okay. Theta of S. So we have to find theta of S divided by d of S. Correct? That will
Yes,
be
sir. Yes, sir.
1 by
Here it is not unit
yes,
feedback, sir. We
because
have to equate it.
that is this is the feedback. So since it is a non-unity feedback, we will first calculate the closed loop transfer function, then we will make it unity equivalent, and that will tell the type of the system. Okay. 1 by 10 S square divided by 1 plus 1 by 10 S square, correct? Into Kp plus Ki by S plus Kd into S. Is it correct?
Yes, sir. Yes, sir.
So that will be equal to 1 by Kp plus Ki by S plus Kd into S plus 10 S square. Correct? Is it correct? 10 S square plus Kp. This 10 S square in numerator and denominator if we multiply, so that first term will become 10 S square. So 10 S square plus this one kp plus ki by s plus kd into s. Okay.
Yes, sir. Correct, sir.
Again, we'll do some multiplication. So, 1 second. So it will be 1 divided by 10s square plus kp plus ki by s plus kd into s. Okay. So it will simplify this one. That will be equal to s divided by 10 sq plus kds square plus kps plus ki. Correct? Any mistake is there?
No, sir.
And
Correct, sir. Correct.
so this is CLTF. Then we'll equate with it g by 1 plus g. G by 1 plus g is equal to CLTF. Then g will be equal to s divided by 10 sq plus kds square plus kps plus ki minus s. Okay. That will be equal to s divided by 10 sq plus kds square plus kp minus 1 into s plus ki. What is the type of the system? What is the type here? See, s to the power 0 is multiplied here, na? So type will be 0. Correct? Is it clear? See here, whatever with the
Yes,
s to
sir.
the power will be multiplied with
Yes,
the
sir.
whole
Type will be zero, sir. Yes.
type 0 system.
Clear, sir.
Okay.
Same type of you have done in the transient alliance.
Previously I
Same
have done.
response concept. Yes, sir.
Previously I have done this. Okay. Okay. So moving to the next question. Hmm. This is a little bit different kind of question. So what is the acceleration error constant with respect to the disturbance input? Okay. So let's say DCF is 1 plus 2 by s plus 3s. Okay. Plus minus. And here plus this is disturbance 1 by 10s square. Okay. DFS YFS. So what will be the see here how we are calculating error, and that Ka is equal to limit s tends to 0 s square into gs. Correct? Then what is the gs? In acceleration constant, this gs is the open loop function. Correct? What is open loop function here? I think g into s we can multiply here. You remember this one? How we are doing? Acceleration constant. What is this gs? G and h we can multiply, I think. So this is feedback. So is it correct? You can reply. I'm doing it. Limit s tends to 0 s square into 1 plus 2 by s plus 3s into 1 by 10 s square. S square will be cancelled. Okay. What will be the value? Infinity. Is it correct?
Yes, sir.
Okay. This only. S tends to 0 into g equivalent means g into h also. So this will be infinity. Okay. Moving to the next question. Should we solve some Bode plot question, like, or we should solve this kind of question only? And previous is the question I will solve first. After that I will come back to the next question. Okay. So this is 2024 question only. Okay. Gate 24. You have covered already Bode plot?
Last week it is covered, sir.
Okay, okay, that's good. So I'll just solve. This is 2 marks question, double E, very easy only. So you see the language. Consider a stable closed loop system in the figure. The asymptotic Bode magnitude plot of the GS has a constant slope of minus 20 dB per decade at least till 100 radian per second. Okay, with the gain crossover frequency be, being 10 radian per second. Okay, so what is omega GC? Can anyone tell what is omega GC? Where this will
That
cross
is grain
0,
crossover frequency, sir.
0 dB line, magnitude will cross 0 dB line. Okay,
Yes,
so
sir.
it is saying that starting it will be minus 20 dB per decade, minus 20 dB per decade. Okay, correct. And this 0 dB is crossing, this is 0 dB, this is crossing at 10 radian, correct. And this is going till up to 100 radian per second. This minus 20 dB is going up to, and Bode plot remains constant minus at minus 90 degree till omega is equal to 10. Okay, so what is the meaning? Minus 90 means that function will be like 1 by s, correct.
Yes, sir. Yes, sir.
Okay, and if one short trick is there, so this transfer function will be in the form of k by s. Okay, k by s. Yes. So how we can find the k? So k directly we can find, this is minus 20 into 1. So omega to the power minus 1. So k is equal to, direct one trick I have explained in the last class, omega to the power n. So 10 to the
Yes.
power minus 1. Correct?
Minus one. Yes, yes, sir.
That is equal to 1 by 10 equal to 0.1.
Yes, sir.
Correct? So 1 second. So what is the steady state formula? Limit ESS, already asking steady state. So already I have told limit s tends to 0, s into
GS.
rs.
RS, yes, sir.
Rs, no? So what is rs here? We'll see. Unit ramp. What is the Laplace transform of ramp signal?
1 by S square, sir.
1 by s square. So s into 1 by s square divided by 1 plus, our transfer function is k by s. This is clear how I have done k by s. Already I have explained na, this k value, k calculation. This I have derived also last class.
Yes, sir. Yes. But K by S means, sir?
K by s is the transfer function of this Bode. So our system GS, GS is
Okay, sir.
equal to k by s, and k we have calculated from this language what they have written. So k is equal to 0.1. So that
Okay,
our
sir.
1 by GS. So 0.1 by s, correct?
Yes, sir.
So what will be the value? This will be 1 by s, and it will go in denominator, that s plus 0.1. Okay, equal to limit s tends to 0, 1 by s plus 0.1. Correct?
Yes, sir.
Any mistake is
Sir,
there?
no, sir. It will be zero point 0.1 by S means S tends to 0. It will be infinity, sir.
1 second, 1 second. Some mistake I have done. K, I think we have done some mistake. I think. Hmm? What is the k value? K is what? Omega to the power. I think here it will be not minus 1. Here it will be 1. Okay. So that will be 10 only. See, I will derive that also.
It should be minus 1, sir. Minus, sir. Actually, it is.
In the reverse way, it will be
But
minus 1.
minus 1 only, sir.
It is minus 1 only.
Yes, sir.
1 second, I will derive that one also. Let me do that. So let's say minus 20 into 1. Okay. So at some omega value, it becoming 0. So k by s, that will be there, 20 log k minus 20 log omega.
Okay, sir. It's omega to the power of n only, sir. One only, sir.
One
Okay,
only,
right.
na? Omega to
One
the
only,
power
one
of.
only, one only, one only.
So this will become 10.
Yes,
This
sir.
we should remember, like for this kind of signal, let's say this kind of signal, it is omega to the power n, okay, minus 20 into n, okay. If it will be like this one, increasing, okay.
Yes, sir. Yes. Then
Here
it
it
is
will
omega
be
to the power minus
omega to
1.
the power minus n,
Minus 1, sir. Yes, sir.
okay. So this is 10, okay. So what will be value here? 10, correct? So
Yes,
s
sir.
plus 10, and our answer will be 1 by 10 is equal to 0.1,
Yes, sir.
okay.
Sir,
So,
how
yes,
do you how do you plot that Bode, sir?
see,
Uh,
I'll
as
repeat
per
it.
information.
I'll repeat it once. Wait. I'll just keep it in the next page. See what they have written. Consider a stable closed loop system shown in the figure. So this is the figure. This is closed loop system. Okay, GS. So the asymptotic Bode plot of the GS has a constant slope of minus 20 dB per decade. Okay. So starting minus 20 only. Okay.
Yes, sir. Yes, sir.
At starting it will be minus 20. Let's say I have started from some k value. Okay, minus 20 dB per decade, at least till 100 radian per second. So it is going like this, and here it is, let's say 100, and this is 10. Okay, the asymptotic Bode plot. Okay, so if something will be there after this, okay, we don't know.
Sir, why it is 10, sir? Why it is crossing at 10? It's
Again,
because of.
crossover frequency,
Okay, sir. Okay. Oh, it is crossing 0 decibels.
0
Okay, sir.
dB.
Okay, okay,
Okay,
okay.
but other information they have not given. It means it should be k divided by s. Up to 100 it is like that.
Okay, sir.
After
Okay.
100 it will add, let's say some pole we add s plus 200. Then what
Okay,
will
sir.
happen? Then
Okay, sir.
I,
Okay.
1 second. Mm, no, so see, other informations are not given, na? That's why we'll assume k by s only.
Okay, sir.
Clear only?
Okay, clear, sir. Clear. It's okay, sir.
Okay, okay. So any other doubt is there, or should we do some more question, or any doubt we are facing in solving other question, that will be more interesting, I think, if you can
Okay,
ask.
sir. Okay, we can move, sir.
Okay, okay. Previous question only I will solve. Some questions are there. Okay. So have you submitted all the previous assignments?
Yes, sir. Till 6 I have submitted, sir. Not except 7.
When is this seventh last date?
It's 13, sir.
13. Okay.
On Wednesday.
Okay. So we'll do this question. Simple only. So same kind of disturbance kinds of thing, and DCFS. Okay. So this VA by E. This one equation is written here. Okay. So this is the controller, I think, VA by E, that is given here. Okay. Kp plus Ki by S. Kp plus Ki by S. So if you do the Laplace of this one, okay. So Va by E is equal to, this is minus is there. Is it correct?
Yes, sir. Minus is there, sir.
So
In equation.
we should take that minus also, I think. If you do Va by E, that is minus Kp plus Ki by S. Okay. So if we'll do Va by E, Va of S, this is output and this is input. So V of S by E of S, okay, equal to minus Kp plus Ki by S. This integral means divided by S. Okay,
Sir, minus is for entire this thing, minus is
entire
given.
total.
Okay,
Okay.
sir. Okay. Because its integration, it is Ka by S. That's it, sir.
Mm-hmm.
Okay, sir. Okay.
Integral if like 0 to 2 t e dt, then it means
Yeah.
it will be Es by S.
Yes, sir. Yes, yes, yes.
Ki into you will do see the Laplace transform, so it
Yes, sir.
will be like this. For
Okay, sir.
differentiation, it is S is multiplied. For
Yes, sir. Yes, sir.
integration, 1 by S is there. Okay.
It's okay, sir. It's okay.
Okay. So now directly we'll put that here minus Kp plus Ki by S, and we'll find a transfer function in terms of Kp and Ki like this one. Okay. So they are asking what is the value of A, B, like A first we have to find. So first we'll try to write the Y of S divided by W of S. This is Ys, this is Ws. Okay. So Ys by Ws I'm going to write. What is the forward path here? Can you tell?
Wait, 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 yeah.
Ys by Ws. This is a forward path, correct?
Yes, sir. Yes, sir.
So
What
that
is
is
ds standard?
minus 1500 divided by S plus 60, correct?
Yes, sir. Yes.
Divided by 1, what this loop gain is minus. So that will be 1 minus minus plus, okay? And this is minus Kp plus Ki by S, okay? And into 600 into 1 by S plus 60. Is it correct? Correct up to now? So that will
Okay, sir.
be
Okay, sir. Okay.
minus 1500, okay, divided by S plus 60 plus minus Kp minus Ki by S, okay. Hmm, 1 second. Minus Kp minus Ki by S, and here it will be into 600 multiplied by 600, into 600, correct? S
Yes, sir.
plus 60 will be cancelled, so it will be minus 1500 S, correct? Divided by what will be the denominator? That one term will be S square plus
60 yes.
60 minus Kp into
60 minus Kp into S, sir.
this 600 also will be multiplied here. Minus 600 Ki by S minus
Yes, sir.
Kp. So 60, uh, 1 second. 60 minus 600 Kp, correct?
Yes, sir. Yes.
Into S, and the third term will be minus Ki into 600
Yes, sir.
minus Ki into 600. Correct only?
Yes, sir. Correct.
So if we take common here, but I think some mistake is there. Maybe. Is it correct? Like minus is here, VA E minus. This minus is coming from here, VA by E. 1 second. Hmm, I think some mistake is there. It should be plus only. VS is equal to KP ES plus KI by SES. 1 second. So first one equation is there, na? Here. This we have neglected. What is this one? Y dash. Okay. But this
Okay.
loop is given here only. I think all the equations are given here only. SYS plus, we write this SYS plus 60 YS is equal to 600 VAS, okay, minus 1500 omega, correct?
Yes, sir.
But I think here this minus should not be there. I think some mistake is there. Already I have the answer, but it is not matching. So we'll solve it by taking this as positive only. Okay, Kp plus Ki by S. So if it will be positive, let's say this is given as positive because here it is negative. So if it will be positive, then this will be plus, this will be plus, correct? And what will be the value here? This will be also plus, this will be also plus, correct?
Yes, yes, sir. Yes, sir.
So A value already we are getting. What is the A value? A is equal to minus 1500, correct?
Yes, sir.
And that what is the, this, it will take common 60. So if I will take 60 common here, what will be the other term? 1
1
plus
plus
10,
10 plus.
10 kp.
Yes, sir.
So
Yes,
B
sir.
is equal to
60.
60. And what is the C value? C is equal
600.
to 600. So C minus B is equal to how much? 540. Right?
Yes, sir. Yes. Clear, sir.
Okay, okay. So like this you can, you said see here. I think it should be plus only. If it will be plus, then only this is correct. Otherwise, if it will be minus, then EFS EFS divided by VAFS. Now VFS divided by VFS divided by EFS will be equal to minus Kp plus Ki by S according to this equation. Okay, right? But it should be Kp plus Ki by S. Here it should
Yes,
be
sir.
plus. Then only this is correct. Okay. Okay. So this is one another question. What is the value of Kp and Ki? Okay. So that the characteristic equation of the closed loop system will have root at this one, the value of Kp, and Ki we have to calculate. Okay. So first I will write the transfer function. Okay. This is the transfer function, minus 1500 S minus 1500 S divided by S square plus 61 plus 10 Kp, S square plus 60, 1 plus 10 Kp, okay, plus what is the last term? 6, 600 into Ki, correct? So how we can solve this one? This is Ys by Ws.
Yes, sir.
So characteristic equation of the closed loop system will have pole at this one. How we can solve it? Can you tell the method how we can proceed? This is the pole. So for if the pole is there, this is pole of this equation. How we can find the value of Kp and Ki? What the
Uh,
step you should follow?
we have to find the second order. If
Hmm. So
come.
based on this pole only, like let's say on pole we can write S plus 60 plus
Yes.
J 60.
60
This is one. And
into
another
S,
one
S
S
plus
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 60
minus
minus,
J60.
correct?
Yes, sir.
So that will be S plus 60 whole square minus J60 whole square, correct?
Yes, sir.
A plus B, A minus B, so A square minus B square, S square plus 120S, correct?
Plus 3600.
Okay. And this is minus how much? So minus minus will be plus.
Yes, plus 3600, sir.
S square plus 120S plus 7200,
00.
correct?
Yes, sir.
So what is the Ki value? 12. 12 into 6, correct? Na?
Yes, yes, sir. Yes, yes,
Ki
sir.
is
Correct.
equal to 12.
Yes, sir.
Okay. And Kp will be 1 plus Kp into 60, 1 plus 10 Kp
is
into
equal to
60, 120.
yes, sir.
Okay. So 1 plus 10 kp is equal to 2.
2,
Correct.
sir. 2. 2.
So 10 kp is equal to 1. Correct.
Yes, sir. Yes, yes.
Kp is equal to 0 0.1.
0.1. Correct, sir.
So K is equal to 12 and Kp is equal to 0 0.1. Okay. So this only was the last question, I think. If you have any other doubt, you can ask. Otherwise, in previous class question is there, but I think already covered. So Bode plot is already done. Na?
Yes, sir.
Good.
Yes, sir.
So today's related other any other doubt is there related to any other question or any other like concept which you have studied and you are facing difficulty. Like, so you can ask me anything.
Sir, regarding Nyquist plot, could you tell, sir?
Okay. Nyquist. Okay. So this
Because
was
we are not covered. Last week it is not covered in your lecture, sir.
it was not, but I have taken some question. But why I have not taken because like all assignments are related to different topic, and I thought that audience will not be interesting. So I
Yes,
think
sir.
some questions I have taken last class only.
Yes, sir. Yes.
Okay, I'll just explain. So Nyquist plot uh, between like phase and magnitude, like in a plus jb, no? Like this kind of plane we are plotting. Omega is equal to 0, some magnitude and angle will be there, and omega is equal to infinity, some magnitude and angle will be there, and there's some rule is there, LHP and RSP. So if it will, I will be interested, I will discuss that in the next class. That is like how the direction will be. Okay.
Okay, it's okay, sir. It's direction okay. If
Hmm.
0 is also given, then how to plot?
Okay. You are asking any example you can tell,
Yes, sir. Yes, sir.
like what if zero will be there? You are asking
Yes, sir.
this only, na?
Yes, sir. Yes,
Hmm?
yes.
So omega is equal to zero and omega is equal to infinity. We'll see the uh, what what will be the magnitude and angle. Okay. So if we see the option, okay. So what is the angle here at this point, and what is the angle here?
Where, sir? Oh,
This
okay, sir.
this
Okay.
point, what is the angle?
It's my
Plus minus
minus.
180.
It's 180 degrees, sir. 180 degrees.
Okay. So what is the like let's say one magnitude 1 is there, one value is there. What is the angle for this one? Plus 0.
0, sir.
If
0.
minus 1 is there, what is the angle?
It's 180.
180 or minus 180. Okay. So based
180.
on this only we'll observe this one. 180 or minus 180 both are same. Because in
Both are
this
same,
type,
sir. Okay, okay, okay.
hmm. So 180. So see which option is the correct here. Okay. So this is the first option. So omega is equal to 0. This term will be 0. Okay. So let's say I'm first discarding the option. Okay. So if omega will be 0, here this is angle is 0. Incorrect. Correct only.
Yes,
Omega
sir.
is omega is I'm putting 0 here. Angle is 0. That is
Yes,
also incorrect.
yes, sir.
Okay. So if omega is 0 here, what will be the angle? Here and here both are, we are getting minus 180.
Yes, sir.
Correct. At omega is equal to infinity, what will be the angle? See, these two options are incorrect. Yeah.
Yes, sir.
So I will just write tan inverse omega by 1. Correct.
Yes, sir.
Minus this is what is omega minus 1. So
Minus.
minus 1, real part is minus 1 and j omega. Correct. This one.
Yes, sir. Second quadrant.
So what will be the angle? Minus tan inverse
180
uh,
minus
minus 180 minus tan inverse omega. Correct.
omega. Yes, sir. Yes.
So 1 second. 180 minus tan inverse omega. So that will be minus 180. No, no. This
minus
is
180 plus tan inverse omega, sir.
correct, na?
Yes, sir.
So what will be the at infinity? What will be the value for this one? This is 90. This is 90. Okay. 90
Yes,
plus 90 minus 180.
0, sir.
0. So this one we are getting. We'll see for this one also. Okay. So tan inverse. What is the angle for this one? J.
This 180 minus tan inverse omega is first one, sir.
180 minus tan inverse omega
Omega. Yes, sir.
and minus. Okay, here also we are getting cancel.
Yes, sir. Cancel. But
Both are
it's
same.
but minus
One second. One second.
but minus minus tan inverse omega will be there, sir.
No, no. This this first one what? 180 degree.
Minus tan inverse omega. That's okay, sir. Next one minus tan inverse 180 minus 2 tan inverse omega will be there, sir.
Okay, but omega is equal to infinity 90, 90, 180, na?
Yes, sir. Yes. It's also 0, sir.
But omega is equal to 0. What will be the there also
180.
it? One second. Let me see once. This is confusing only. One second. So omega is equal to 0. S plus 1 divided by 1 minus s. So um, I think second option. Um, One second. Omega is equal to 1, Gj omega is equal to minus j G1, G2, S plus 1 by S minus 1. Okay, so see, at omega, some middle value also we should check. Okay, initial final will not check. Okay, hello.
Yes, sir.
Let's say omega is equal to 1. I'm checking value that omega is equal to some point. Have you installed MATLAB in your like
No, sir.
PC?
No, no.
So if you do that kind of analysis, then it will be more clear. Okay.
Okay, sir. Okay,
So
sir.
let's say omega is equal to 1. What will be the angle contribution for which one? Like this is which one is neglected?
Yes, sir.
Uh, this is neglected, na?
Ah,
And
second one, first one neglected, sir.
these two are neglected.
Yes, sir.
So so omega is equal to 1. What will be the angle for this one? So this
Omega.
is 45, 45,
Yes,
90. That will
yes,
be
sir.
minus 90.
Yes, sir.
Hmm?
Yes, sir.
But we are not getting minus 90 here. No, omega is equal to 1 will some will come here, here to here. That minus 90 we are not getting at 1. But here if you'll see plus 90, na? Omega is equal to 1
Yes, sir.
plus 90. So if we are not getting the option, so we should check the mid value of the whether angle will be positive or negative, and accordingly we can discard the answer. Is it clear?
Okay, sir. Okay, sir. Okay.
Okay.
Okay, sir.
Okay, so
Thank you.
any other doubt will be there, you can ask. Otherwise, we can.
Okay, sir. Okay, sir. No, sir. Thank you, sir.
Okay, thank you. So we'll meet on the next Sunday. Okay.
Okay, sir.